Good morning, ladies and gentlemen, here in New York City. Good morning, good afternoon, good evening. If you're joining this general session out there on the World Wide Web via Syscon TV pages, 1,800,000 of them, so you should be able to find Rex. Rex Wang, VP of Infrastructure and Management for Oracle, spoken here before, one of our favorite speakers. He's going to go through the roadmap to enterprise cloud computing. You know that's our focus at Cloud Expo. Let's give it up for Rex, and I will not steal his time.
Morning, everyone, and welcome to today's general session entitled Roadmap to Enterprise Cloud Computing. My name is Rex Wang from Oracle, and I lead Oracle's go-to-market initiatives around cloud computing, virtualization, systems management, operating systems, and related products. Today's talk is going to be about what we see customers doing as they take their journey towards the cloud. Therefore, it's entitled Roadmap to Cloud Computing. We're going to cover what we see as customer best practices, as well as give you some real-life customer examples of what people are doing. With that, let's start. In the data center, today there are a number of trends that have been happening for a number of years. We actually think that cloud computing is the logical evolution and continuation of what's been happening to IT for the last decade or more. Today, here are some of the trends that we see. Many data centers are moving from physical environments to virtual. I think this is a mass market trend. We see probably 80 or 90% of our customers doing this in some form or another. They're moving from dedicated environments where each application runs in a dedicated stack, if you will, to a shared environment where resources are pooled and shared amongst multiple applications. They're moving from a heterogeneous environment which mixes technologies from multiple vendors, multiple versions, to a more standardized common architecture to reduce that complexity to minimize some of the costs of maintenance and ongoing modifications. They're also moving from fragmented manual management of these virtualized systems to a much more integrated and automated approach. You really need that integration and automation in order to manage in this new dynamic environment. Another shift we see is that many companies are moving from systems that are managed exclusively by IT to more of a self-service mode for certain applications, allowing end users to self-service provision, self-service monitor, self-service manage. And then lastly, we see a trend towards how products are integrated. Today, customers are still integrating products on the floor of their data centers. They're choosing products from multiple vendors in a best-of-breed approach and doing that integration themselves. But we see a clear trend towards the adoption of what we call engineered systems, which are integrated and optimized combinations of hardware and software, pre-assembled, pre-integrated at the factory and delivered to the customer in a functional way. Here are some of the things that we see. In terms of general trends, the general data center trends we see look something like this. We see an evolution going on in private enterprise clouds, and we also see a similar evolution going on amongst public clouds. On the private cloud side, many companies have data centers that exist in these silos. Each application runs in a dedicated silo of dedicated middleware, dedicated databases, dedicated servers, and storage. These silos are physical environments, they're fairly rigid, and they're mixed, they're heterogeneous. So you might have an Oracle stack, for example, standing alongside a Microsoft stack, an open source stack, stacks from other vendors. This mixed environment leads to a lot of complexity, a lot of brittleness when it comes to integration, a lot of higher costs as well. There's a clear trend towards consolidation. People are moving from these siloed environments to these shared environments, leveraging technologies like virtualization, moving from vertical silos to shared pools of resources. We see that this consolidation can actually be happening at different levels. For example, at the infrastructure as a service level, leveraging virtualization technology, for example. But it can also be done at higher levels, like the platform level, which would include technologies like database and middleware. So what I mean saying there is that companies are choosing to standardize on a common architecture for database, a common architecture for middleware, and choosing to consolidate at that level. This is a significant trend in the market. We see a lot of customers, moving towards this. This trend is by no means done. We see consolidation sort of at the 20 to 25% level on average, but it's clearly going to increase as we go forward in time. From here, the view is that many of our customers are extending towards a much more cloud-like environment by adding certain things like self-service, where end users can, again, provision their own resources, monitor them, and manage them to within certain constraints imposed by IT. Also, policy-based resource management, that is the ability to scale elastically the resources required based on policies or rules. Because these resources are shared, there's the need to measure how much of that shared resource is being consumed by each application or user, and you typically use that for charging back to that department or end user. And then also adding the need to do capacity planning in a new way, because we're doing capacity planning for pools of resources that are shared by multiple applications, as opposed to sizing hardware for a specific discrete project or product. So we see this evolution happening. Not all applications are likely to move from the left of this picture to the right of this picture. Some apps will remain in their silos because they're maybe very, very mission critical and cannot be shared. Maybe they're very stable and they don't face dynamic workloads. So there may be a reason to just leave applications where they are in their silos under certain conditions. But other applications certainly can be consolidated, and that consolidation can happen at either the infrastructure level or platform level. We'll talk more about that in a moment. And then other applications will benefit tremendously from end user self-service and sharing a private cloud. A similar evolution is going on in the public cloud space. In the past, there have been many service providers of different kinds: ISPs, ASPs, MSPs, traditional telco operators, and traditional ISVs as well. All of these service provider entities are morphing to become cloud service providers, either the SaaS variety, the platform variety, or the infrastructure variety. Today, there's probably hundreds of these service providers out there. They're very popular. A lot of them are gaining quite a bit of traction. They're very specialized, though. They tend to do one thing and one thing well, and then that's good for sort of making sure that they can deliver service in an economic manner. They want to deliver a very specialized, consistent, and standard service. And they're very isolated from each other. It's very difficult to move one workload from one place to another. But they're still, nonetheless, quite popular. Our view is that the evolution of the industry is moving towards this notion of a hybrid cloud, where applications can actually run across both public and private and are highly portable and interoperable. It'll be possible to move an application workload from one public cloud to another, from your private cloud to your public cloud, and vice versa. Of course, this hybrid environment requires standards. The standards that are not fully in place yet, Oracle is participating in the standards development process with a number of vendors, including a number of you in the room. And as the industry establishes standards, the vendors will create technologies to comply with those standards, and that'll enable, this portability and interoperability that everyone is hoping for. That eventually you'll be able to have a lot of choice in terms of where to deploy workloads. You'll be able to do true cloud bursting, where you might run a steady state workload in-house, and then when you see a peak in the workload at the end of the quarter or at season time, high season, you'll suddenly burst out and use a public cloud's capacity for that purpose, and then return that resource to the pool when you're done with it. That's a very interesting scenario that some people call cloud bursting, and that'll be enabled once we have true interoperability standards and the ability to do hybrid cloud computing. This is kind of the evolution that we see happening in both the private cloud side as well as the public cloud side. We ask ourselves all the time, what exactly are our customers wanting? What are they doing? One of the tools we use, of course, is surveying our customers. About 6 months ago, we did a survey of about 300 customers through the Independent Oracle Users Group. This is not Oracle, but this is an independent users group. The people that we surveyed were indeed Oracle customers. And we asked these customers a number of questions. What are you doing? One of the findings that we had was that only 14% of our customers seem to be using public clouds today. In contrast, 29% have private clouds today, and another 15% are actually in planning or under consideration. So I think, let's pause here. These two statistics I think are interesting. First of all, I don't see that these numbers are over 50%, so they're not quite mass market, but I think you can see that they're well beyond the I'm curious early adopter stage. So we do see, customers really adopting the cloud or accelerating on that adoption curve, moving towards greater and greater adoption over time. In fact, we're doing this survey again in a few months, and I do expect both of these numbers to increase. One of the other questions we asked our customers was, why are you choosing private clouds over public clouds, since it seems to be, twice as popular? And I think this is no surprise to anybody in the room. The top concern that most people have is around security and privacy. Also, long-term cost, also quality of service. These are some of the top concerns that people have around using public clouds, and that's why we think they're using private clouds. So if you're using private clouds, we asked what type of private cloud they had, and our finding was interesting here. We found that amongst private clouds, private platform as a service was actually slightly more popular than infrastructure as a service. Here's some of the data underneath that. So internal services like application server as a service and database as a service were slightly more popular than the infrastructure level services such as compute and storage. And I think if you did this survey and asked the same question about public cloud adoption, these numbers would actually be reversed. You would find that infrastructure as a service is much more popular in public clouds compared to PaaS. But in the private cloud situation, it's clear to us that there's greater customer interest in and adoption of the platform. Now, if you think about it, I think it becomes really clear why that might be true. When IT is providing a full private platform as a service to its end users, it's delivering greater value. It's delivering a platform upon which developers can create their applications much faster, much cheaper, with more reusability and sharing rather than reinventing the wheel from scratch. In addition, the platform offering creates a level of standardization that's much higher than simply offering, basic infrastructure. By providing a standardized database and middle-tier architecture to application developers internally, it creates a much more standardized environment, so it minimizes some of that heterogeneity and complexity, which leads to higher cost. That's why we think we see, more interest in and adoption of PaaS compared to infrastructure as a service. So I think the learning that we have is kind of captured in this slide. Infrastructure as a service, very valuable, but it really still only offers basic compute, storage, and networking services. The application complexity and heterogeneity continues to exist on top of the infrastructure. And that's the biggest driver of cost and complexity. By offering a platform as a service, PaaS really simplifies and standardizes the application foundation and allows the organization to standardize on that. Orgs still have to invest development resources to maintain the applications, but at least they're living on a common architecture, a common platform. At the top of the stack is the SaaS layer, where these are ready-to-use applications, used by end users. Let's not forget, though, that these still require some ongoing configuration, customization, integration activity. So there's still a need to modify them, but there's clearly less of a need at the higher end of the stack. So, the insight here is probably not that new, but we believe that the higher up a customer decides to standardize their architecture, the more value that they're achieving and the more cost savings that they're going to achieve. Let me share with you a couple of customer examples. Here are two of Oracle's customers that are implementing private clouds. In fact, they've been doing it for a number of years. Both of these are from the financial services industry. On the left is Credit Suisse. The right is Commonwealth Bank of Australia. Both of these customers have been on this transformative journey towards cloud computing for a number of years. And both of them have implemented private platform as a service. Credit Suisse has been doing it for about 7 years. They actually have 3 different platforms. They have a Java platform that's based on WebLogic, a database platform that's based on Oracle Database, and they also have an infrastructure as a service platform based on computing. And over the past 6 or 7 years, they've added things like a self-service interface as well, and they've attempted to consolidate more and more of the bank's applications onto one of these 3 platforms. In doing so, they've achieved significant cost savings, as you can see. They've also reduced their power consumption, and in fact, they've actually increased their uptime or availability. On the right, the example is from Commonwealth Bank of Australia. They have a service that they've had for, I think, at least 4 years, 3 or 4 years, and they call it Oracle as a Service. That's their name for it. It's actually based on Oracle database, and what they've done is they've consolidated over 300 applications onto 3 different grids. The 3 different grids vary by service level, by how mission critical they are. And they've implemented a chargeback model to pass these costs back to the lines of business who are responsible for those applications. So again, this is a case where the customer has decided to consolidate and standardize on an architecture, in this case Oracle database. They've recently taken Exadata, which is Oracle's database machine. It's an engineered system that I'll talk more about in a little bit. So they've taken kind of another step in that evolution to achieve even greater benefit and greater cost savings. You know, when I asked these customers, I was down in Australia a few months ago, and I asked Commonwealth Bank of Australia, how do you manage to encourage the lines of business to move on to your shared platform, you know, to a standard platform, as opposed to just do their own thing? And their answer I thought was interesting and insightful. What they said was, when a customer, when an end user approaches them and asks for a certain, you know, database service to be provided, they ask for a certain level of requirements, and they want it delivered at a certain cost. And what IT is able to do at CBA, they're able to actually over-deliver on those requirements at a lower cost. So in essence, their method of encouraging consolidation and standardization is to offer a better service at a lower cost. In essence, they're competing with other alternatives that these lines of business could be using. I found that to be interesting because it's a clear indication that, you know, IT is viewing themselves as a service provider, an internal one, but a service provider nonetheless, and they must offer competitive services in order to encourage that adoption of the standard platform. So this is the outline for the rest of my talk. I'm going to continue to describe a little bit more about the roadmap to cloud computing. We think that one of the first steps in that roadmap is definitely consolidation. Consolidation means moving on to a standardized, shared, and elastically scalable platform, with the eventual goal of moving to this notion of a private platform as a service. We think that that's the logical direction for many enterprises. Next, I'll talk a little bit more about our engineered systems and why we think that they're the best foundation for both consolidation as well as private clouds and public clouds as well. And then finally, you know, we'll talk about the full cloud computing lifecycle, about why cloud computing really requires a lot more than just simply looking at individual technologies. You need to be able to look at the entire lifecycle from development to you know, ongoing management to how do you secure the cloud, how do you integrate the cloud. All these aspects need to be considered as well. So first, let's talk more about the consolidation as a logical first step to the cloud. I showed you this picture earlier, so really I'm talking about that initial step in that process of moving from silos to standardized, virtualized, and shared platforms and infrastructure. One of the basic questions that most enterprises will grapple with is this question of, you know, at what level do I do consolidation? Do I consolidate at the platform level, you know, onto a shared and scalable platform? Or do I do consolidation onto infrastructure? I might use virtualization technology, for example, to put multiple applications onto shared hardware, shared servers. But, you know, that does nothing to reduce complexity. It does nothing to reduce that standard, to reduce that heterogeneity. And so that can be done without standardization. I think, you know, both of these are valid to some degree. So, you know, the question was, which one do I do and how much of it do I do? With respect to consolidation, a lot of people think about virtualization as a key enabler. Virtualization is often associated with both consolidation as well as cloud computing. And it indeed is a very useful technology to enable sharing, to enable flexibility in terms of application deployment, et cetera. Definitely a very valuable technology. But I just wanted to remind everyone that there are other technologies out there that are also required and useful. For example, clustering. You know, so if this diagram tries to illustrate the difference between the two, server virtualization, as everyone knows, is a way to make one physical hardware, piece of hardware, look like multiple virtual pieces of hardware. To contrast that, clustering is a way to make multiple pieces of hardware look like one. And what we think is that these two technologies are highly complementary and really go together well. Again, cloud computing is often about sharing and elasticity, and it's also about highly available services. With respect to elasticity, if you really had server virtualization only, how would you scale an application beyond one physical box? It turns out you still need clustering technology to do that. So when you talk about elasticity, virtualization alone is not going to do it. You need some form of clustering technology to enable you to scale beyond one physical hardware box. Another example that I like to talk about is availability. A lot of virtualization technologies do provide, quote, high availability, but when you dig in a little bit and try to understand what that means, what that really means is that, imagine that physical piece of hardware going down, having a failure of some kind. What has to happen is that failure has to be detected, and the application has to be picked up, the virtual machine has to be picked up and then moved and put onto another working piece of hardware. During that period of time, your application is actually down. So it is high availability in the sense that you're able to easily detect a failure and move it to a working piece of hardware and spin it back up. But during that period of time, it's down. If instead you had a clustered environment, it can survive individual node failures of both hardware and software without any interruption in service to the application. So I guess you could think of that as more continuous availability versus high availability. My point is that you really need both in order to implement consolidation in cloud computing. Oracle really has a wide selection of products in these areas. We're the market leaders in some of the clustering areas. For example, the RAC, the real application clusters capability of our database is famous for being able to elastically scale by adding and subtracting nodes dynamically without any interruption in service to the application. But we also have clustering at different levels of the stack, including our ×10 in-memory caching layer, including the WebLogic application server layer, including the coherence in-memory data grid. So we have clustering up and down the stack. On the server virtualization side, a lot of people talk about bare metal hypervisors running on commodity x86 servers. We do have a hypervisor called Oracle VM for x86, but we also have other choices too. For example, we have another one called Oracle VM for Spark, which is a bare metal hypervisor for Spark architectures. There are even other alternatives as well, including Solaris containers and zones, which are a form of OS level virtualization. My point here is simply that in order to sort of do the right, most optimal thing, you're going to need a combination of virtualization technologies, different ones, combined with clustering technologies. And it's that combination which really delivers on the elastic scalability and the resource pooling that's part of cloud computing. This is another slide that tries to illustrate that. Imagine that you've decided that you're going to do consolidation of multiple applications, but you're going to do that at the database tier. You decided that you're going to standardize on Oracle database, and you want to put more and more applications onto that shared database platform. Well, it turns out that there's different alternatives. You have different choices here. Here's 3 basic choices. The one on the left shows how you could do database consolidation using virtualization technology, in this case, Oracle VM. There's 3 different applications there: data warehousing, CRM, and ERP, using a virtualization architecture to share hardware. The middle scenario actually doesn't require Oracle VM. It uses the operating system's capability to isolate workloads. Here, there's actually 3 instances of Oracle database running, as you can see, and we're not actually using virtualization at all, but we're just using the operating system's ability to isolate. The middle database, because you can see it spans 2 different hardware nodes, is a rack database. The other 2 databases, the data warehousing one and the CRM one, are actually not. So this is a case where you're able to share without necessarily using virtualization technology and without necessarily using rack. The version on the right is the situation where there's actually a single instance of Oracle database. It's a rack database, as you can see, spanning multiple hardware nodes. And that one database is shared by multiple applications. Each application has their own schema. So there's different trade-offs, different technical trade-offs involved when deciding which of these options to choose. My point is just to show that it's possible to do shared database consolidation, mixed workload database consolidation with virtualization technology, with clustering technology, or with neither. Really, the same approach can be said at the middle tier. If you're doing consolidation at the application server level, you also have three very similar choices to make. The version on the left uses server virtualization. The version on the right is a single clustered instance of WebLogic running across two hardware nodes. And there's the middle version as well. So the same choices can be made at the middle tier as well as the database tier. My point in kind of sharing these different options with you is to kind of show what customers are doing, the choices that they have, the technologies that they need as they make that first step on the road to cloud computing, which is consolidation. The next topic that I'll try to cover is engineered systems. You know, we believe that engineered systems are really the ideal foundation for cloud computing. And really, the industry has undergone kind of an evolution. You know, there are best-of-breed products in different categories, and many customers have chosen a best-of-breed approach, choosing multiple products from multiple vendors and integrating them themselves to form these solutions. Indeed, Oracle believes it has, you know, best-of-breed products like Oracle Database, like WebLogic, which are both #1 in their categories. And, you know, this approach is still a very valid approach. It still works, but I think the industry is moving. You know, what this chart tries to show is that as the industry strives for improved performance, improved efficiency, that is the vertical axis, as well as improved manageability and improved simplicity, we're going to move to the upper right of this picture. Starting with best of breed, but moving on to these Oracle, you know, optimized solutions, and then finally to these engineered systems, which are really pre-integrated and optimized combinations of hardware and software that perform very specific functions. The two examples that I'll share with you today are Exadata and Exalogic. Exadata is Oracle's database machine, and Exalogic is a machine for middle-tier application workloads, like for Java, for example. Both are highly optimized and pre-integrated. When I say optimized, they're optimized for a variety of characteristics, but the chief one amongst them is performance. Because Oracle owns the entire set of hardware and software necessary, we can uniquely engineer these hardware-software combinations together to deliver a step function, an order of magnitude improvement in performance. Because of that increased performance, they're also much more efficient in terms of consolidation. Many of our customers have taken hundreds of applications and consolidated onto a single one of our engineered systems, for example. So the optimizations that we have performed are chiefly around performance, but they also lead to improved manageability, improved security, improved supportability as well. The fact that they're pre-integrated by Oracle at the factory and delivered to customers in a functional manner shortens the deployment time. I've had a customer come up and tell me that you know, I was able to implement Oracle Database RAC, Real Application Clusters, because I got it in a pre-integrated fashion via Exadata. And previous to that, they were not able to do that. So there was tremendous value in being able to receive a complete database machine that was pre-integrated and functional on day one. Let me tell you a little bit more about these machines. First, the Oracle Database machine. As I said, this is an integrated and optimized combination of hardware and software. On the hardware side, Exadata combines x86 compute servers with storage, that is disks, connected via a very fast InfiniBand network that actually operates at 40 gigabits per second, which is incredibly fast, much faster than your typical Ethernet networks that interconnect your systems. On the software side, the components include Oracle Database 11GR2 with Real Application Clusters and automatic storage management. This machine also includes a very special type of storage software that actually runs on the storage server rather than the database server. And in fact, this unique architecture is what delivers some of this breakthrough in performance. It's part of the secret sauce of Exadata, part of these optimizations. By moving some of the database functionality from the database server to the storage server, we're actually able to do some of the processing there and return only the results back to the database server. So it reduces the amount of data that's transferred between the storage server and the database server, which really helps speed up performance. And oh, by the way, these are connected via InfiniBand, which is already a very, very fat pipe anyways. There are a number of other optimizations in addition to that. We've also delivered, caching technology that's totally transparent. We've delivered compression technologies as well that allow you to store more data in this machine as well. This machine comes in different configurations. It comes in a quarter rack, a half rack, a full rack, and it scales up to 8 racks wide. There's also a version that uses bigger servers. So the X28 machine uses 2 servers that are 8 sockets each. There's also an X22 machine that has up to 8 servers in it, 2 sockets each. So I don't want to go through too much of the technical details of this machine, but at a higher level, what we've seen is that this machine is really an ideal target for consolidation. You can put both data warehousing workloads as well as transaction processing or even batch processing all in the same machine. So it's a real great way to consolidate multiple and mixed workloads onto one consolidated and shared platform. Exalogic is another engineered system that Oracle has come out with in the last year. The hardware components are predominantly compute servers. There's also a storage appliance in here as well. It's for the storage of images and application files. And the networking technology is InfiniBand once again. But it's mostly, from a hardware perspective, it's mostly compute servers, x86 compute servers. And this machine also comes with special software that optimizes its performance, especially for Java workloads such as WebLogic, our application server, as well as Coherence, our data grid. So in essence, this machine can serve as the compute platform while Exadata is a storage platform, and both of them can be interconnected via InfiniBand. This makes both of these machines really ideal platforms that are for applications that are sensitive to performance and are very, very efficient for the consolidation of many applications together onto a common platform. Next, let me talk a little bit about the complete cloud lifecycle. So, we've already talked a little bit about Exadata and Exalogic as the base platforms for cloud computing and why they make ideal foundation for the cloud. But that's not all you need. When you talk about the full cloud lifecycle, there are many other aspects. For example, how do you actually do application development on the cloud? Well, we actually have a number of solutions for this as well. There's a class of developer that, let's say that they're hardcore application developers. They're developing new applications that might be enterprise class or departmental, but they're developing them from scratch and they're using tools like Eclipse and JDev and NetBeans. We support that type of application developer, but there's also, let's not forget that there's also a different kind of developer need out there. Once you've got an application, let's say a SaaS application or perhaps some other packaged application, there's still the need to extend it, to customize it, to integrate it. Many times, this level of extension is not done by a hardcore programmer. It might actually be done by a business analyst. And we provide a number of tools to enable these business analysts to do application extension and modification. For example, we have a number of composer technologies that enable this type of developer to create reports, to change their business flows, to modify the data that they see on a page, to add data elements to that page, things of that nature. So we're supporting both hardcore developers building new apps as well as business analysts who need to extend and modify existing apps. Another critical aspect of cloud computing and looking at the life cycle is management. Our belief is that you really need a comprehensive management system to be able to properly manage the cloud. You need to be able to manage the cloud in the complete manner from the application tier all the way down to the middle tier database, server, storage, and networking, the whole thing. If you're only going to manage, let's say, the virtualization layer, but you have no idea what's running in that virtual container, you really have no hope of managing what the end user experience is going to be. You can't find and detect failures or problem areas. You need to be able to drill down into diagnosing the problem. So that's why you need really the visibility and an integrated approach that Oracle has. Oracle's product for this is called Oracle Enterprise Manager, and it does indeed manage the entire stack from applications all the way down to disk. On top of this sort of basic management functionality, there's a need for additional functions to support cloud computing, specifically things like self-service provisioning. You need an application that's used by end users that manages their rights and entitlements and privileges. You also need a way to measure how much of the shared resources are being consumed, that is metering, and you need a way to do chargeback if you're talking about a private cloud, or billing if you're talking about a public cloud. You need a way to establish policies for how to scale these resources. We call that policy-based resource management. You need a way to do capacity planning, because now we're procuring hardware and we're procuring software in a pooled fashion. We need to buy a pool of hardware that's going to be shared by multiple users and applications. And you need a way to do assembly packaging, which is our term for how do you package perhaps a complicated multi-tier application for rapid deployment in a repeatable and error-free manner. We have technology that enables us to package up applications that are bigger than a single virtual machine. There might actually be several virtual machines and several tiers, and to easily deploy that onto a cloud. So here are some of the capabilities that you're going to need in the management space, and we believe we have a very comprehensive solution for this as well. Another key issue is security. It's one of the top issues around cloud computing. There's a variety of issues here, but one of them is, of course, managing user identity, user access. What are specific users authorized to do? Can we audit that? How do we provision users? How do we deprovision them? How do we enable single sign-on across the cloud? Users who might be using internal applications as well as applications provided via a public cloud. How can we manage users across that cloud boundary, for example? Also, in terms of information protection, you're going to need to secure your data, of course. We provide a number of options at the database level to do that, including a database firewall, including audit capability, encryption capability, things of that nature. So a variety of solutions spanning both identity as well as database security. Another issue is integration. A lot of times applications are not standalone. You might want to be able to move them around, but in fact, it's difficult because they need to be integrated with other things. And so in the case where customers are running, let's say a public cloud service for, let's say, CRM, as this illustration shows, they might also be running a number of other applications internally in-house. And these applications, unfortunately, are not standalone. They need to talk to each other. There's a number of issues that they might have, and we provided a number of solutions to enable that integration, including some of these shown here, including business process and SOA integration. So you might have a business process that spans internal systems as well as that external cloud service. You need to be able to integrate that business process using SOA, using BPM technologies. Also, at data integration, you might have data that initially is in-house, but you need to load it to the external cloud service. And then once data changes, how do you maintain synchronization across that cloud boundary? We provide a number of solutions for that, including Oracle Data Integration and Oracle Golden Gate. So, in summary here, I think users should think about the complete cloud lifecycle, not just, consolidation onto, the platform, but also issues like how do you do new application development? How do you do ongoing management of the cloud? How do you do security of the cloud? How do you do integration of the cloud? In summary, let me wrap up here. We believe that cloud computing is really kind of the continuation of the journey that many customers have been on for a number of years already, that moving towards a more dynamic, a more shared environment, for example. One of the first steps in that roadmap to cloud, we believe, is consolidation onto a shared and elastically scalable platform. That consolidation can actually be done at different levels. It can be done at the platform level, which requires standardization onto a common architecture, or it can be done at the infrastructure level, which allows that complexity and heterogeneity to continue. In some cases, customers are doing both. They're consolidating at both these levels. But we believe that consolidation is kind of the first step that many customers should be thinking about as they move towards cloud. The ultimate goal, we think, is logically the platform. By offering a full platform for developers, it's going to offer greater value. It's going to decrease time to market for new application development. It's going to increase component reuse, minimize costs, minimize complexity. Secondly, we believe that engineered systems are really the future, and they're an ideal sort of foundation for cloud computing. Engineered systems provide, significantly better performance and therefore better efficiency for consolidating mixed workloads. They also deliver their solution in a pre-integrated way so that customers can get to deployment much faster because they can be stood up in a much more rapid fashion. And then finally, in looking at cloud computing, we need to think about the full cloud lifecycle. It's not good enough to think about one or two components only. We can't just be thinking about virtualization. We can't just be thinking about database. We can't just be thinking about hardware and storage. We really need to look at the whole thing holistically, the full lifecycle from deploying the cloud, deploying applications onto that cloud, managing the cloud, including patching it and so forth, scaling the cloud, securing that cloud, integrating the cloud, et cetera. And I think that you should think about all these aspects when you're looking at how you might move towards cloud computing. I think that wraps up my talk today. So I wanted to thank you all for your attention, and thank you. Have a good conference.